This episode is going to rock your world. This is the Remarkable Regional Business Podcast. I'm Caleb Maxwell, and this episode is wild. I am talking to Steve Durkin, the founder of Safescape. I've really got no words. The stories, the insight into the way this man thinks is pretty wild. So I hope you have as much fun listening to it as I had doing it. Take it away. Steve, thanks so much for joining us in the Emporium studio today. It's really an honour to have you in here.
Thanks, mate. Yeah. It's great to be in Bendigo and at the Emporium. I didn't know this place existed.
Yeah, well,
cool.
Here we are. Let's start at the start, okay? Could you paint me the picture for those who have never heard of Safescape? What is it? What does the company do? And paint the picture of the scale for me.
Okay, so we are interested in improving the efficiency and safety of mines through the creation and distribution, production, delivery of products that help them make their lives easier, improve safety, reduce emissions, blah, blah, blah. So That's what we do.
Right. And tell me a little bit about a few of those products. So, and it started with the Laddertube, is that correct?
That's right. So Laddertube was the reason for Safescape being created. So Laddertube is a ladder primarily designed to be used in underground mines as an escapeway, as a safe escapeway, which is kind of where the company's name originated from. And that was a concept that I had from must have been about 2004, 2003. I can't remember exactly off the top of my head, but it took me 5 years. I tried to get others to take it on. Like, I would have been happy to sell the concept or receive some sort of commission on sales, but nobody thought that a plastic ladder would work. And so I was unable to convince anybody. And in the end, about 2008, I started working part-time and working on it a bit more. 2009, I stopped work completely and just focused on it. 2010 was when the first install of the product was done here in Bendigo at the Fosterville Gold Mine.
Wow. And so let's just take a little bit of a rewind back to the start where you're talking about now. What were you doing while you were, coming up with this idea, and how did you really take the leap and launch into creating your own company and manufacturing the product?
Yeah. So I had the idea at a time when I was working for a mining contractor that we did a lot of underground narrow vein development and stoping and contracting. And so I got to do some really cool stuff, and I loved that work. I just loved that work. And one of the jobs that I did was to mine the risers. Like, you stand on ladders, drill holes above your head, blast them with explosives, then go back and extend that rise and continue going. And then you install ladders into those risers, and that's what's used for escapeway. So the escapeway exists in case the main travelway, which is either a shaft or a decline tunnel, in case that gets blocked, that there's a way out for workers. And it's a regulated requirement all over the world that you must have that in place before you begin production from a particular area. And so it's a requirement, but for years and years and years, we'd been using either steel or timber ladders, and there are problems with steel, particularly underground in Australia, particularly Western Australia, because the water is just so salty, but also anywhere where you've got a metal mine. So you're talking about copper, nickel, zinc, lead. The water tends to be acidic, and it will strip that iron out really quickly.
Wow.
Like sometimes it's less than a year, and that steel is no longer safe, no longer structurally stable.
Wow.
Yeah, so... And it was an unpleasant job. I didn't like having to, because my job was to mine the risers, which I loved. Yeah. I was able to use equipment, and I had the right fall arrest and all that sort of stuff to work in risers. So all these rusty steel ladders, I'd be asked to go and do that work while I'm on site to fix these rusty steel ladders. I did not like doing that, and I'm like, well, why should we be fixing this, doing a dangerous, it's a dangerous job to fix it. Yeah. It shouldn't be there in the first place. And to be honest, the idea of Laddertube was just a fully formed idea that just snapped into my mind one night as I was going to bed.
Wow.
And I didn't sleep that night. I wrote it all down, did some research on the internet, found there was nothing like it, and 2 weeks later I had a patent application in, and
Wow.
pretty wild. But 5 years of trying to get it out there. I love my job. Like what I did was so cool. I did not want to stop mining. But come 2008, I was feeling anxious, which is not a feeling that I'd had before. And it took me a while to figure out what it was. But what it was that this idea was not being delivered. Right? And so as soon as I realised, oh no, I have to do this, that anxiety went away. And I put in place a plan to be able to leave that job, trained up others to do my job, and then slowly left. So it wasn't a snap decision to leave or anything like that. It was planned.
Wow. Okay, that's amazing. So why Bendigo? So you said it's manufactured in Bendigo. Is that where it kind of started, or what?
No. So I'm originally from Kalgoorlie and met my wife in Kalgoorlie. We were both mining engineers at university studying mining engineering, and she had a job in a mine in Kalgoorlie, and I had a job for a contractor based in Kalgoorlie that did work all over Australia. And so, for years I would be travelling, sometimes 6 days a week I'd be away from home, travelling to various locations.
Wow.
And it was not conducive to a quality relationship. And at that time, that company I was working for had jobs here in Bendigo Mining, Fosterville, out in Malden, Castlemaine, Stawell. Like we had jobs around the place. And this was one area that I could come and live and be close to a lot of the work that we had. So she took a job at Fosterville, and so she was working out there. I based myself here. We bought a house out in Mandurang, and that's when we started Safescape. So because we started the business here, the admin team and the installers and everyone that was working for Safescape was here. We were contract manufacturing in Victoria, not in Bendigo. And in the first 12 months from when we started, they increased the price 300%.
Oh my goodness.
They didn't, the company that was doing it didn't really care so much about quality. And they certainly didn't care about schedule, timing. So if we would place an order and we knew that they could do it within, say, 4 weeks, and we need it to go to a mine site week 5 because they need it installed, otherwise they can't produce their gold, nickel, copper, whatever it is, that's a real problem for them. You have to deliver on time.
Yeah.
And so we couldn't get them to understand, plus the 300% thing was out of control.
There's a common thing in business that you say you can pick like cheap, fast, and good. You can pick 2. They already missed 2 of those, cheap and fast.
It wasn't good.
No.
And so, like my job previously was to be given a set of drill hole data and say, this is how much it's going to cost to mine that mine, which is going to take 5 years and use this many people and this much equipment, right? So there's a lot of moving parts in that.
Yeah.
Big spreadsheets. Lots of logic. And this is a process that requires a machine, labour, energy, and material.
Yeah.
Right? Not many parameters, right? No. So I ran the numbers using quotes from brand new equipment, rented facilities in Perth, and I'll explain why we chose Perth. And I'm like, we can get this price down to, even at low volume, we can get this down to what it was originally.
Wow. And
I told the manufacturer, I said, look, we've decided that we're going to do this for these reasons. So I explained what the problem was.
Yeah.
And he was like, oh no, you're going to go broke. That's a crazy idea. You've got no idea. You won't be able to do it. Well, yeah, I get that it's not easy.
Yeah.
It's just that it can be done. Therefore, we can do it.
Yeah.
And we're going to do it. So we did that and bought a brand new machine from a Canadian company, rented a facility in Forestfield, Perth, and started doing it. None of us had ever done anything like it before.
Wow.
It's just like, well, these are the rules of the game. This is how the equipment operates. Let's figure it out.
I love that.
And the very first one that we made was good to go, and we used it. So
wow.
Yeah, it was actually not as hard as what it was made out to be.
Wow.
To do it. Yeah. And we chose Perth because in Australia there's a freight deficit from Perth to East Coast. So trucks are all full heading towards Perth, and half of them were empty coming back to the East Coast. And so from Melbourne to Kalgoorlie, freighting ladders to there was costing us more than freighting them via the port to Spain. And it was costing us more to fly to Kalgoorlie than it was to fly to Spain. Like, this is the ridiculous thing. So So we set up the facility in Perth, and that's great because we can get product freighted to central New South Wales from Perth cheaper than we can from Melbourne.
Wow.
Yeah.
That is wild. That's a good decision. Right. So you've launched into this manufacturing kind of process and you've kind of nailed it to start with. What was the journey of getting it from, first installs and getting in your first couple of mines to going global and to being a real dominating force in escapeways?
Yep. So the very first one that we installed, I set up a ladder in my back shed, and I asked the superintendent out at Fosterville to come to my house. I didn't tell him. I said, come to my house, have a beer. And he came for a beer, and I said, climb that. He climbed it. Whoa, this is cool. So do you reckon it might work? Yeah. Because we kept it fairly quiet.
Yeah.
Not for any sort of fear of it being, stolen or anything like that. It wasn't about that. It was just that there's no point telling people about it until, in my opinion, wait until it actually works and then tell people about it.
Yeah.
Rather than spruik a story that takes you 7 or 8 years to actually come to fruition, which is hard when that happens. So he said, yeah, no, I reckon, okay, I think it'd probably work. I said, all right, here's the deal. Next time you're in an escapeway, buy a steel one, have it on site. I'll come and install this. If you like it, you buy it. Same price as your steel one. If you don't like it, I'll pull it out and I'll install the steel one for free.
Wow.
And he's like, okay, let's do that. So we did it.
Wow.
They liked it. They left it in there. And that steel ladder was sitting on the surface for years.
I bet it was.
Yeah, and they still use it out there today. And so from there, we were on the New Inventors. I'm not sure whether that really did much for us on ABC New Inventors. I don't know if you remember that.
Yeah.
That was a couple of months later. And I set up a big trailer and with a section of ladders on it that I could assemble with a small crane on the back of the ute in a car park so that people could climb it.
Oh, wow.
Because in the mining industry, people need to feel something, just like physically feel it. It's one thing to see it, that's good, but feeling it makes a big difference, right?
Wow.
So we actually drove that around, visited, I think, 15 mines, met with mining regulators, state regulators, and did all this, like set it up in people's car parks, got them up and down, climbing it, understand, okay, well, it might work. And most of those sites that we visited ordered ladders from us within 2 years. And so it sort of started like that.
Right.
And then people move from one site to another because a lot of mines in Australia fly in, fly out. So it's really easy to just change jobs. You don't have to move house. It's easy. You just got a different schedule for your flights when you leave each week and away you go. So people take the good ideas with them from site to site after that. So it wasn't like advertising or anything.
Yeah.
But we did benefit from, this is 2010, 2011, 2012. Search engine optimization wasn't a really well understood thing, or it was like real estate and a little bit of tourism was starting to sort of use it a bit. So we used it when we set up our website, and it was super effective.
Wow.
Our key search terms for underground escapeway ladders, and they're not called many other things in the world, was like at the top every time.
Wow.
And so we started to receive inquiries from around the world through search engine optimization.
Wow.
Every country, and in fact, in between states or provinces of some countries, you'll have different regulatory regimes that affect various products, and certainly ours. So we take Canada, for example. Several of their provinces had specific regulations that would preclude the use of Laddertube, and most of them didn't. We knew that when we designed the product. We're like, what are all of the regulations across the world, and let's find the design that fits the vast majority of likely areas, markets where we would expect people to use it.
Yeah.
So one particular market, which we knew was a good market potentially, but we couldn't design it to meet that was Quebec in Canada.
Okay.
And we couldn't do it. It made no sense to do it. We didn't want to do it.
Right.
Like we theoretically could have.
Yeah.
Made no sense. So for years we got asked by Quebec mines, can you make it like this so that it meets our requirements? And we'd say, look, we could, but we're not going to because it makes no sense. That regulation is 50 or 60 years old and it shouldn't be there.
Yeah.
It makes no sense.
Yeah.
Like I'd rather, because it'll just cost you more and it doesn't make sense. No one else would use that design, so we're just going to stick with our current design. And that was a bit of a bit sort of big-headed to sort of make that statement, but the reality was it just made no sense.
Right.
So I think must have been about 2013. We had a big mining company, a big global mining company that has some mines in Quebec, came to us and said, look, we really want to use it. It's going to make a huge difference for our mine, and we're willing to actually change the law.
Wow.
Will you support us with that? And got on a plane, went over there, met with them. So they'd teed up this big group of various stakeholders across the industry, mining companies, contractors, health and safety, labour unions, all this sort of stuff. And they're like, right, this is the current state of affairs. This is this product. These are the rules. This is why we can't use them. This is the law that we want to change.
Wow.
Everyone agreed, let's do it. It took them 7 years. 7 years to get the law through.
Oh my goodness! Like a common sense kind of this is better change of the law.
It takes a long time because there's no big push for them to do it. There's no pull. There's no government pull for them to change that law.
Right.
It's being requested by stakeholders that are affected by the law, but so it took a long time. Anyway, I think it was 2020 that it was finally put into legislation, and the last 2 years that's been our biggest single site has been in Quebec.
Wow.
And they're a great customer, some really great people there, and when I say the biggest single customer for the year, it's I think 5% of our sales. So
right.
The top 20 make up about 50-60%. Typically.
Wow. Yep. Wow. That's a really good diverse kind of breakdown of you don't have single or low number client dependency. That's pretty amazing.
Yep.
Is that due to the other products you produce as well, or is it just due to the volume that you service? So
what it is that pretty much not every, but I'm going to say maybe 90% of underground hard rock mines, all of your gold, nickel, copper, diamond, even some stone mines, but not coal, typically. They all have to have escapeways. There's various ways you can get around it, but it's uncommon to do so. And so they have to have them. But they're a very small part of what they do. Like it's just a small part that sits over on the side that we have to do, so we will access that when we need to and find a way.
Yep.
It's not a big thing that they really think hard about in their early stages.
Yep.
So because every mine needs it, but it's not really important in terms of signing up a big contract and locking in terms and whatever else. They just run along. Like some of our customers will, one particular in Western Australia, ever since the beginning, which was I think for them late 2010, it was fairly early on for us, they would order and expect them installed within 2 weeks.
Whoa.
Like their first phone call would be, we need another 40-metre ladder, want to install it in 2 weeks.
Whoa.
And because we spoiled them a couple of times early on, they just thought, this is how we roll. And so we just order the week before and they get it, right? So they've consistently been able to get that. Most customers think, 2 or 3 months in advance, but these guys were like, no, every 2 weeks behind. Yeah, we'll let you know. And
that's pretty impressive that you're able to meet that though. Is that on the freighting it to them?
Oh yeah, everything. Everything.
Holy.
So I'll give you a cool story.
Yeah.
We had, because like I say, these are a requirement in order to produce from an underground mine. They have to be in good nick.
Yeah.
And so steel ones rust.
Yeah.
Right? So over time, they can become a problem. Now, if you wait too long and all of a sudden one falls out or gets crushed or gets blocked or the mines inspector comes along and says, that's not safe, you're shut down, right?
Whoa.
That's happened a couple of times.
Whoa.
It happened right up in the north of Western Australia. We had a phone call. We got a big problem. We got a 160 metre steel ladder that's been, the department has shut us down, needs to be replaced. Wow. And it starts in the bottom of an open pit mine. Normally open pit mines have a ramp that goes down. You can drive down to the bottom of an open pit. Mm-hmm. But their ramp had failed. Like a big ground fall had collapsed the ramp, so you couldn't drive down there. So you've got this open pit mine with a 160 metre ladder in the bottom of it going down into the mine, and the mine's shut down. Like no one's allowed to produce from the operation.
Whoa.
So it was, I think, 9 days from the first phone call to the job being complete. 160 metres, right? We've got a big 5-tonne winch. We've got 160 metres of ladders. We've got to get it up to site, but then we've got to get it to into the pit. How do we do that? Helicopter.
Yes, you do.
Helicopter.
Yes.
Yeah.
Wow.
I know. It was crazy.
That is crazy. So did you assemble lots of bits and then put it down, or bit by bit, like up and down?
It was 4 at a time. We were able to grab 4 at a time with a rope and just sling them down, boom, 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 down in there and away. So that was incredible. Because
that is incredible.
I think it would have been costing them, probably more than $500,000 a day.
That was my next question,
production.
right? Yeah. That's very, very valuable for you to solve that problem.
Absolutely. So for a steel ladder of that length, back then, this was like 5 or 6 years ago when we did that one, it would have taken minimum 8 weeks.
Oh.
I mean, these days, sometimes it's taking 6 months for people to get a steel ladder.
And you did it in 9 days.
9 days. I'm talking about just to fabricate it. In that particular case, we couldn't have made the ladders in that time frame and installed it in 9 days. It would have taken us 2 weeks. But that's a lot for them in that moment, right? Where it's critical.
Yeah.
But we had a customer who we were about to ship an order to, which was in Canada, and we said, guys, is it all right if we redeploy these and just push your shipment out a week?
Wow.
No problem.
Oh,
and so they were like, yep, understand, fully appreciate that.
They would understand better than anyone.
Absolutely. And so then another example of that was a mine in Canada was shut down for their escape waste. Same thing. They were losing $2 million a day, and they told us, like, this is absolutely critical. Like, how fast can we get them? Like, whoa, it's going to take 5-6 weeks to get them by boat. Now, it would take 8 weeks to make a steel ladder in Canada. So it's already faster to do it by boat. What about plane? So we ended up putting like 100 metres. It was sort of like, it must have been over 3 different large planes. It would have cost them 10 times more in airfares for the ladders than it did for the actual ladders themselves.
I mean,
but they did it because it was critical. Yeah, so it's great that we can do it fast.
Wow. I mean, I've been in a Hercules before, and there, it would have had to have been that scale of plane, right?
Yep.
Huge. Wowzers. Okay, that's very, very cool. Obviously, an incredibly valuable service and product, and you've got some mad wins on the board there. Let's just wrap Laddertube up with, to date, do you know the number of how many meters of Laddertube that's been installed in mines across the world?
I really should have done my homework before coming in.
I know.
It'll be plus 70 kilometres. What is it? Do you know?
No. Well, if it's over 70 Ks, it's on an email signature that I've seen recently. It's more than 50,000 metres.
Yeah, I think it's a lot more.
Wow, that's so cool. Yeah. That must feel pretty amazing. How does it feel to know that this light bulb idea that you had ages ago has turned into that?
Well, it makes me feel a bit tired, actually, because there was a period there for a few years where every time we got a new site, I would celebrate it by running the distance of ladders that we'd totally installed, right?
No.
Yeah, but when
did it overtake your capability?
Oh, in the mid-20s, I'm like, we can't keep doing this.
That's so good. I love that. All right, so that's Laddertube, and that is amazing. But that's the starting point. What? Tell me about your growth in terms of product manufacturing since then. There's the most recent one is pretty humongous, and I'd love to pick your brain on that. But what was first? Like, how did you step up being able to sell to the same customers but with other products?
Yep. So our second product was Multi-Bund, which came about at a time when there were a few, in Australia they're called boggers, in other countries it might be a mucker or an LHD, but it's a front end, an underground specific front end loader basically, that were falling into big voids because of insufficient rock bunding. They would normally put a rock bund in front of the hole, and then hopefully, the bogger wouldn't be able to drive over it or push through it. Right? It was originally designed to stop these boggers, these front end loaders, from falling into stopes. However, that's just one job, and because of the size, it's essentially a very large plastic lane divider type thing that you would see. We see thousands and thousands of them at roadworks and events and stuff like that. So we know what they look like.
Yeah,
it's like that, but bigger and much heavier duty. And so we designed it to be able to do a few different jobs on mine sites. That's why it was Multi-Bund as opposed to bogger stop or something like that.
Right.
And that works really well. It's great. And it hasn't been adopted anywhere near as much as what Laddertube has. But it's because it's, for example, if it's used as a bogger stop, you're looking at a capital investment of about $4,000 to install a bogger stop in your underground mine, and you might need, say, 20 of them in total. A steel one will cost you $20,000, and why would you use that? It makes no sense.
That's right.
The Multi-Bund's very easy to move around, whereas the steel one's very hard to move around because of the design of it.
Yeah.
And so for me, it's a no-brainer. And some people recognise that, but it's a relatively small purchase compared to a 50, 60, 100 metre ladder. It's a bigger purchase, so people think about it more. And so it hasn't been adopted as much. But
interesting.
It's a good product and it works.
Yeah. Okay, that's Multi-Bund. What was next?
Next was a product called paste hole cover, which was a concept that a customer required. A customer that had been using Laddertube and Multi-Bund for quite a long time. It was in fact the first new mine that started, like first underground started after Laddertube it was created and offered in the market.
Yep.
And so there's a few of them now, but that's a mine that has only ever had Laddertube as a skateboard product. So, and one of their guys was like, we've got this thing that's, it's steel and it weighs like 10 kilos and people keep getting hurt with hand injuries and shoulder injuries using them. Could you make one that's like exactly the same but plastic? And we looked at their designs. Well, we're not going to make it exactly the same. How about this design? Oh, yeah, that'd be great. And so it was mainly for them that we made it, that one customer. And I think they probably bought 80% of them that we've sold. Like,
wow.
We've shown it to people and others are like, oh, yeah, whatever. But that particular site, love it. And then Edge Protector was the next big one. So 2016, we come up with Edge Protector. That is an awesome product.
Yeah.
Which is still very early in its adoption.
Yep.
But say we've got like 20 or something customers, 5 countries. Mm-hmm. It's successful. It's just that what it can do is incredible. So if you, on the edge of an open pit haul road, a ramp going into a mine, you've got a pile of rock that sits like that. And that pile of rock is theoretic. Like some people think it's there to stop a truck from going over the edge, right? Because that used to work when you used Model T Fords, right? Because a Model T Ford tyre would hit that bund and the axle would snap and you'd just plough into the ground and that would be the end of it.
Right.
So these things are typically regulated to be half wheel height.
Yeah.
In some countries it's 2/3 or 3/4 wheel height. It doesn't matter. Trucks just drive over them because the wheels are enormous. They're 4 metres diameter.
Wow.
nearly 5 metres diameter, some of them. They're
Nothing
enormous.
snapping that axle. No amount of rock stopping it.
No. So that, I would have been, back when I was at uni, maybe 90, 98, I was driving trucks at a mine not far from Southern Cross in Western Australia. And I woke up one morning at about 4 a.m. with my front left-hand wheel right on the top of the bund, fully loaded, going uphill, right on top of the bund, and I could look down the bottom of the pit 250 metres down.
Oh my goodness.
And there's the digger that I'd just been loaded half an hour earlier. And I steered back onto the road and kept going up to the waste dump.
You'd fallen asleep?
I'd fallen asleep driving uphill. So your foot's flat on the floor, fallen asleep, driven up the bund, woke up, looked down, steered back into the road.
Oh, man.
Nothing is stopping these things going. These trucks are enormous and the pole of rock doesn't move. There wasn't even a mark on that pole of rock.
Oh, my goodness.
You just drive over it. And it's uphill, loaded.
Wow.
So imagine downhill empty. There's no problem. Like, you just go straight over.
Wow.
Right? So what Edge Protector does is it creates a vertical front face of that bund. So your tyre hits it and you deflect back inside.
Right.
No question on a tight angle of collision that you're just going to come back in. You won't drive over.
Yeah.
So that's great. That's about 90% of the possible interactions. But then if you hit it normal to the line of the bund, you've got a line there and you've got a corner and you hit it normal.
Yeah.
A normal rock bund, you just go straight over the top.
Yeah.
You sail straight over the top unless you put your foot on the brake. Right?
Yeah.
But with EP, what happens is it has to push, has to plough all that rock instead of driving over. It's much easier to vertically push the mass over than it is to push an entire pile of rock to the outside.
Yep.
And so we thought, this should work. It has to work. But we knew that we would need proof that it would work, like some scientific evidence behind it to get, because this is something that they think is this pile of rock they think is a safety thing, right? Now, anyone who drives trucks knows that that's not going to stop you from going over, right? Yeah. They know that because they have done it. Like, same thing as me.
Yeah.
And so we thought, all right, we've got to prove it. So we put we were able to access some grant funding to do some research.
Okay. And
this grant funding was up to $50,000. So it would be matched funding. So we could, if we spent 50, the government would give us 50 and we could spend $100,000.
Yeah.
And so we went to UWA Maths Department, UWA Physics Department, Curtin Maths, Curtin Physics, and asked them for proposals. 3 of those proposals came back costing $100,000 and taking anything from 6 to 12 months. One of them, the Industrial Mathematics Department at UWA, the 2 professors came out. These guys are, at that time, in their 70s. Right? Yeah. Loveliest guys. They come out and they're like, we just think this is great. We've already got a solution. We're pretty sure we need to test it, but we're pretty sure we already know what the answer is. Like, oh, great. So we are so excited because we do industrial maths. We travel all over the world showing people why something happens the way it happens when it doesn't make any sense. And no one ever tests our theory. No one ever tests it, but you're going to test it. You are going to test it, right? Yeah. We're going to do this. We're going to get a big dozer, and we're going to push a big plate with load cells in it. We're going to measure, so we'll know whether your theory is right or not. Oh, that never happens. So we'll just do it for free. We'll do it for free. And I said, no. You can't do it for free because, like, I need to be able to say that your university, I need to have an invoice to say that you've done this work for me, right? Oh, okay, no worries. Okay, we'll talk to them. Like, I think it was $5,000 or something.
Oh my goodness!
Yeah, and so they came up with this theory, and it was a beautiful theory. And they ended up publishing the work that they did in in the Australian Industrial Mathematics Journal. And essentially, what it says is there's a little bit of friction on the rock and the bund on the surface. Uh-huh. There's a little bit of inertia in moving that amount of material from A to B, but the vast majority of the force is actually in the rock rolling over itself. It's internal friction as you're pushing it, and it rolls over inside, and that's that's most of the force. Really? And sure enough, like no one had ever tried to calculate what that force would be.
No.
But they did. They're like, well, if you add this and that and the other, it's a complicated little formula, but they figured it out.
Wow.
And so we put all that into a spreadsheet and calculated what the resistive force of a bund would be based on the height of the rock pile behind it and the specific gravity of the material. And then we set up a 50-metre EP bund up at a mine site in Western Australia and pushed it with this big dozer. Just made it stall up against these EPs.
Wow.
But we then tracked the points on the graph, and it was just on the money. Like their calculation. I've never done an experiment that worked that well.
Wow.
It was perfect from the get-go.
That's amazing.
They did amazing work, and so we're able to say to a customer, all right, you've got a rock bund and a potential situation here. Your truck weighs this much. It's travelling at this speed. If it hits it, you're going to need 4 metres of space for it to, if this is and we can tell them this is what will happen, right? Which has never happened before.
That's amazing.
Yep. So that's a great product. But the best thing about it is, it's safer, right? There are some mines in the world where, like up in the Andes, where it quite often gets snowed, and so they'll be driving trucks and be icy conditions and there's snow and low visibility. Well, there's mines where for the last 30 years they've lost a truck over the edge every 2 years.
Oh my goodness. Right? Wow.
The average is one truck every 2 years. Now that truck costs them $3 million, but there's a person that dies each time that happens, right?
Wow.
It's a real issue.
That's massive.
Yeah. So aside from the life-saving thing, which is obviously really important to me because it fucking nearly happened to me, right? But the other piece is all this space is created, either created or saved, depending on what the situation is. But if you need to mine an open pit that's 400 metres deep, that's up like this, and then with your ramps, you remove 2.5-3 metres of ramp width that you don't need, and you bring that wall up like this. I'll give you a crazy example.
Yeah.
I think early 80s there was a really big mine in Chile that was it's still operating and will be for some time, Escondida, that in their feasibility study, the overall pit wall slope sensitivity per 1 degree was $1 billion US net present value for the project in 1980 something.
Per 1 degree.
Now we would get them 2, right? 2.5, right? So back then, that's what it would have been worth. Now today, if they changed to it today, it'd be worth more. Partially because of the time value of money, partially because they're processing lower grade material and stripping costs are higher. If they did it now, the impact to them would be a lot more than $2 billion US increase in profit.
What?
I know. That's an extreme case.
Talk about measuring the value of a product and being able to communicate that to a customer and make a lot of sense and be a no-brainer solution. I don't think I've ever experienced a better one than that. That's wild.
Yep.
Saving lives.
Absolute no-brainer.
Potentially billions of dollars in certain areas. Wow. That's crazy. Wow.
Well, and then because you don't have to move all of that waste to access the same amount of copper, nickel, gold, whatever it is, you don't have to drill, blast, dig, haul, store all of that additional material. So you don't have to put diesel into those trucks and loaders and this and that and the other. So say a 400 metre deep mine using EP, the reduction in diesel consumption just by the digger and the trucks is the same as taking 9 million passenger vehicles off the road for a year. Right? Australia has 13 million passenger vehicles. We have a lot of open pits that are that deep. Right? I know. So if you're talking about reducing emissions and it matters to you, move less waste. It's the best way to do it, right?
That's phenomenal. You're talking about one open pit mine being able to remove like 9 million in equivalent in diesel.
They burn a lot of diesel.
That is incredible.
It's incredible.
That's like a bunch of open pit mines. That's more than the entire amount of passenger vehicles in Australia equivalent.
If Edge Protector gets picked up by, in the same sort of adoption rate as Laddertube, for example, we will do more for emissions reduction than Tesla. Like really, a lot more.
That is so wild.
Yep.
Man, I had no idea it was that cool.
It's really cool.
Whoa. All right. So You've just blown my mind, but let's go into. I'm really interested in how you've approached building this business, right? Because you had this great idea to start with, and it worked, and it was legendary. And then, what's the process that you go through as a founder and a leader of going, what's the next thing? Or was that always a question in your mind of what am I going to do next and how are we going to build this company? Like what's your process there?
It's not a process like that where it's planned. The things will come into my mind for some reason, whatever reason it is at the time or however it happens. And Edge Protector, again, was a fully formed idea that popped out while I was drawing a picture on a whiteboard for some of my people. And I'm like, oh, stop everything. We need to get this down.
Wow.
So that sort of crazy stuff happens. And then, so you do a lot of thinking about how to then take that idea and what is the best way to develop it. So Edge Protector, for example, while obviously a great idea from the first inception of the concept, it was like, this is going to cost us millions to prove, right? This is going to cost us millions to get to a point where it works. And we can't do that. It's too easy to make. We can't do that if we can't protect it from a patent perspective, right? And this is the big problem, right? This is the biggest challenge that we've had with Edge Protector is we wouldn't have made it. Even though it was an obviously good idea, we simply wouldn't have done it from a business point of view if we couldn't get IP protection, if we couldn't get patents.
Right.
So we were able to, fortunately, because no one had ever done anything remotely close. I mean, it's essentially a modular retaining wall. It's not complicated, but from an application point of view, no one's ever done anything like it. So we were able to get patents pretty much most countries, most mining countries anyway. And unfortunately, that means that when a big company, a big multinational mining company that has a lot of open pit mines and could achieve hundreds of billions of dollars improved NPV and reserve growth and all of these things that they want because it increases their share price, they can't buy it from us because it's too important. Like we were talking about ladders before not being important to them. They have to have them, but there's options and it doesn't really matter. So we just do a tender each time and we supply and we get the supply from the company that we like. Edge Protector is different. Once you start using it, you can't go back.
Right.
Because you've committed to it.
Yeah.
And if you go back to a normal pile of rock, no one on site's going to be happy about it because you've just reduced the safety by a considerable margin. Your insurers won't be happy about it either. B, you've got less space. You can't run trucks that are the same size, right? So you've mined the pit to use it, so therefore you have to keep using it.
Wow.
That's complicated, right? Because it's all right if you're a very large public company and you're sole sourcing a critical item. There's lots like that, lots of examples of that in business and the mining industry. But when you've got a private company and you're sole sourcing a critical item, you'd rather not make those hundreds of billions of dollars extra profit, increase your share price. You'd rather not.
Are you serious?
Because of the risk that once we decide to use it, or like if they increase the price dramatically, or if they become embroiled in some problem and they can't supply to us, or they become busy and we can't get it when we need it.
The risk outweighs
the risk of doing it. I know. It's crazy.
Billions of dollars.
It's crazy.
That is crazy.
It is. And so when these people in these sorts of companies sit down and they say, well, but we really do want it because it really makes a big difference for us. How do we do it? So what they do is then they put out a big, like typically they go through a different organisation, like a industry think tank or body or something like that, not directly, and they'll go through them and they'll put out a fatality risk mitigation challenge. This is the problem. These are the things that we need to be able to solve that problem. Can you do it? And they put it out as a big innovation challenge, right? Globally.
Righto.
And then, so that's happened to us twice.
So it's a bit of a sneaky move to try and, they know what the solution is.
Oh, yeah.
They want someone else to come up with a different
that does the
version
same
of it
thing.
that does the same thing.
It's your problem, guys, to beat their IP. But we need it. We need options here, right? So that was the thing, and so that's happened to us twice.
Wow.
Once here in Australia, and we submitted our answers. Big company. Yes, we've spoken to some people, but maybe there's people in there that weren't aware of it, right?
Sure.
And so we submitted our answers to the questions and showed them what we already had and had tested and proved. Got no response. But it happened in Chile as well, and that was funny because the company that the organisation that did the challenge was like a federal government sort of innovation think tank type organisation. They put it out, and so what they put out was some of it was like cut and paste from our marketing documentation.
Oh my goodness!
Yeah. You could look at it on the website and go,
It wouldn't pass the plagiarism test.
No, it wouldn't pass the plagiarism test. AI should have picked that one up straight away. So it was like, okay, well, we know where this is coming from because we'd already supplied a customer over there, and they had quite an amount of the product, and so we sent in our application explaining this is what it does, and they actually rang me, which blew my mind. I expected an email. They rang and said, "Oh, we just got your application. It's exactly what we're looking for. And have you supplied this to operation?" Yeah, we have. "Oh, have you supplied any to Chile?" "Yes." "Oh, yes, that's going to make it so much easier." "Which mine site?" "This mine site." "Oh, but that's our customer." "Yeah, I kind of figured it might have been." "Oh, okay. Well, we'll send it through to them, and then, didn't hear from them again."
And so they didn't know.
No, they didn't know.
Oh, that's hilarious.
I know.
Oh man.
But it's not hilarious, right? It's actually pretty sad because
it is,
literally, a couple of like every 2 years, truck goes over the edge in these operations over there. It's a real thing, and the benefits for them are far more than just the safety benefit. I'm not trying to say that the safety benefit is not important. It really is. I really want. So if these guys had have come to us and said, "Hey, we're worried about sole sourcing a critical item from a small company. How can we resolve that?" Awesome. Let's have a conversation about that.
Yeah.
Because there's many, many ways that we can deal with that.
Yeah.
Like we can license it to you. We can license it to somebody else.
Yeah.
We can work with you to establish a facility that supplies your business. How do you want to do it?
Yeah.
We can have a contract that says that if we're unable to supply, you're able to then outsource. I don't care as long as you're using it because it makes all of these things better.
Yep. But they didn't have the conversation.
They don't have the conversation. And how do you have that conversation? I've tried to bail up executives at conferences and stuff and have a conversation, but they get a bit scared. Like they don't like to talk about stuff sensitive like that.
Wow. Well, they'll just have to listen to this episode of the podcast and then maybe that'll bring them around. Okay. We have, I thought we would be much further through the journey by now, but there is so much gold in your story and your products. It's phenomenal. How do you go? The big question on my mind is how do you go from manufacturing kind of molded? You said the edge protection is pretty simple to make. How do you go from producing those type of assets and products to an electric vehicle?
Yeah. So 2 things. You've got to be super naive, right? So the statement that I've always had is if it can be done, then we can do it. The question is, should we?
Right.
The question isn't, can we? If it can be done, then we can do it. The question is, should we?
Right. And
that's a bit naive, right? Because it is actually super hard.
Yeah.
I'm going to confirm that right here. But it's the same thing. It's about safety and efficiency and emissions reduction.
Vision, right?
So in underground mines, you see in the news the big open pit mining companies, iron ore companies in particular, and some of the coal ones might be even talking about it, or they don't like to talk much publicly, but certainly the iron ore mines. They talk about hydrogen trucks or battery electric haul trucks and stuff like this on the surface. That's all well and good, but I think that's primarily hype, right? Underground, we are regulated to pump a certain volume of air per minute through the mine per kilowatt of diesel engine in the mine. We still have to pump air through to get rid of the dust or the explosive gases from blasting. But mostly it's about the heat and the emissions generated by diesel equipment that we need to pump a regulated amount of air through the mine. Now, if you think about an underground mine, it's essentially a long series of tunnels. It's like a big network of straws. And if you get a straw and you blow through it, a bit of air comes out. Blow through more air comes out.
Yep.
When you try and blow a lot of air through it, no more comes out. Right?
Yeah,
it's the same.
Right.
Yeah? So you get to a point with the fan that you're blowing air through the mine that you can spend 100 times, like you can double the amount of electricity that you're putting into that fan, and you'll only get 10% more air out, right?
Right.
And so because that happens, the incremental cost of air at an average underground mine in Australia for a Toyota Land Cruiser, right?
Yep.
The average cost to meet that regulation in energy, I'm assuming 10 cents a kilowatt hour energy cost, is $150,000 a year per Land Cruiser that you operate underground.
And how much is a Land Cruiser to buy outright anyway? Like
70,
80. But it costs almost just under double that to actually
just to pump air through for it. Yeah. So if you change that Land Cruiser to being electric, whether it's an electric Land Cruiser or a Bortana, what we make, you're beauty. We don't need the air for that cruiser. Yep.
Yeah.
So it's a big potential win there.
That's massive.
Yep. It's much bigger underground than it is on surface in terms of the operational cost benefit of electric equipment.
Yep.
The human health aspect again is a lot bigger. So we use diesel underground for two reasons. One is there's no carbon monoxide, no reasonable amount of carbon monoxide, whereas petrol cars, there's carbon monoxide, right? You don't want to be breathing carbon monoxide if you can avoid it. But the problem with diesel is it has diesel particulate matter, which, to be honest, we're only really starting to understand properly today. And the research that I've done indicates to me that the DPM is going to be a really big issue maybe not in the next 10 years, but in the next 20 or 30 years, because when we first recognised that it was an issue, when people were dying of cancer from diesel emissions from on airports, or there'd be lots of people like cancer clusters and stuff nearby, diesel emission, heavy DPM concentrations. And so they recognise these things. They've done the studies, and they said, right, we need to reduce the DPM in the air, and they do that by filters. And so they'll put a filter in the exhaust pipe, and it'll filter out all of the bigger particles, and that'll reduce the amount of diesel particulate in the air by 99% by mass.
Okay.
But not by count, because the big inert particles make up the vast majority of the. Okay, they're not actually this big, but these big particles are inert, large particles of carbon. But the really, really small ones are so small that they'll go in your lungs, they'll go in through your alveoli and out into your blood and into your cells, and they'll find themselves in all various different areas of your body, right?
Wow.
And when you had big inert ones in the air and small charged ones in the air, the charged ones would stick to the big inert ones. They'd get stuck in your nose hairs, and you'd blow out black boogies at the end of the day.
Right.
And you go, okay, pretty dirty air, black boogies. Yeah? Not good. It can't be good for me, black boogies, right?
Right.
But at least those little ones, the dangerous ones, were getting stuck to those ones and getting caught in my mucus.
Wow.
Now the air looks clean down there, but I'm telling you, it is not.
It's worse for you. Wow.
It can be made cleaner. You can get special filters. Typically in Australian mines, we're not using them yet. In Europe, you have to, and they use them. But here, we don't have regulation around stopping these nanoparticles. Wow. And I've got these nanoparticle detectors, and I've done some assessments at various mines in Australia, and I can categorically say that the air we're breathing today is worse than it was 20 years ago.
Wow.
Yep.
Wow. Despite the best efforts, right?
Despite our best efforts.
Wow. So I had no idea about that, but the cost benefit for a EVs I'm assuming would be a lot more expensive than a Land Cruiser, especially if not made at scale.
Yep.
But there's got to be, that's got to catch up eventually, because I mean, I've worked in a couple of mines in video work before, and I had a bit of mine water drop in a camera once, and camera dead. It was game over instantly. But there's got to be a wear on those Land Cruisers, right? There's got to be a lifespan to a Land Cruiser. Mm-hmm. What is that, like 1 to 2 years?
1 to 3 years. Yeah.
1 to 3 years. How are you kind of manufacturing, and what's your design thinking when it comes to Bortana, and the benefit or the trade-off between how long an EV is going to last, one of your EVs is going to last, as opposed to a Land Cruiser?
Yeah. So again, it comes back to what we did with Laddertube. We built a ladder that doesn't need to be replaced. We've got mines with 50-year mine lives. There's only one choice for them. They're going to use ours because they don't want to replace it 10 times. Yep. So it's the same mindset. We decided we wanted to try to make an electric underground light vehicle, because light vehicles are problematic. They cost a lot to maintain. They don't last very long, all that sort of stuff. And the diesel, So we decided, okay, we're going to do this. But what vehicle will we use? Because we're not going to design one from scratch. Like, that's too hard. That'll take too long. We can't afford to do that. So we need to find a donor body. We didn't even consider the Land Cruiser because, yes, it would be easy because that's what everyone already uses. And so, it seems to make sense to them, we should just use an electric Land Cruiser because we've already got the parts and everyone knows how to drive them and fix them, which is fair enough. Like, that's a reasonable approach. But they corrode. They've got holes in the chassis. It's quite thin steel. The same. You're retiring a vehicle at anything from 20 to 40,000 kilometres travelled, right? I mean, they are. I could show you some photos. They are completely rusted out.
Wow.
There's no structural integrity left in the vehicle.
Wow.
Yep. And I mean, some of these vehicles are costing $10,000 to $15,000 a month in maintenance costs to keep them operational.
Oh my golly.
Yeah.
That's huge.
It's out of control.
Yeah.
Because they're not designed for that. Sorry, Toyota, I've got two Land Cruisers and I really enjoy them. They're great for the bush.
Yeah.
They're not great for underground. It's just that they're the only car that you can get in any volume that lasts any length of time, and the manufacturer supplies all of the parts that you will break when you operate them underground.
Right, so they're not a bad option. They're just the best.
They're just the best.
A bad set of options,
essentially. That's my position on it.
Yeah.
So anyway, we searched the world. We found 3 possibilities. There was one in prototype stage in the US, one in prototype stage in India, and one in production in Brazil. So the Brazilian one interested us the most because it was already in production. We could go and see them being used. Went and visited the company's called Agrale. Went and visited their factories. It's a private company, but quite big. They've been around for about 60 years. Mostly make buses and trucks and tractors. But they, about 15 years ago, were asked by the Brazilian military to design a vehicle that would replace their Hummers, and it needed to be smaller, have a higher payload, use less fuel, cost less to maintain, and last longer.
Right.
Okay.
How's that all?
Okay. So they built this thing that they call the Mahua, which is it's a water buffalo that's native to the South of Brazil.
Yeah.
So the Mahua is a beefy car, right? It is very, very rugged and strong.
Yeah.
And I went over there and visited the factory, and I'm walking along, and there's a couple of doors there getting ready to be assembled. They haven't been painted yet. They're galvanised. I said, what's going on here? Are those doors galvanised? Yeah. Is there anything else galvanised? Yeah, the whole body's galvanised. Why isn't that on your website? Like, why don't you promote that? No one else does that. Oh, well, how else are we supposed to make them corrosion resistant? Yeah, fair point. Right? And the chassis is sealed. Like, it's a box section chassis, a typical sort of like a tractor chassis, but it's sealed. So it can't rust from the inside.
Wow.
These cars were being used underground in the heavy use case role in Brazil, lasting 8 to 10 years, right? Where a Land Cruiser will only last 12 months in that role.
Oh my goodness.
Yep.
That's crazy.
And they cost about twice as much as a cruiser, as a diesel, yeah? So
that's
but they last that much longer.
Yeah, that's like 5 lifetimes of a Land Cruiser.
And they also carry 4 times as much weight and are the same dimensions.
Oh my goodness.
They're like a pocket rocket.
Wow.
They're pretty beefy, and they carry, you can carry 2.5 ton in them.
So these things are wild. How has not the rest of the world caught on and are using encased, galvanized?
Oh, it's very hard and expensive. Right. So,
okay.
We're talking about a car that can carry, say, 2 ton, but it costs 150 grand Australian on road, right?
Mm-hmm.
So what other cars cost that much? You're basically looking at an imported Silverado or Dodge Ram or something like that from the US. That fits that category in terms of price range and load capacity. That costs a lot because if you've got to change it from being left-hand drive to right-hand drive, they're not actually built as a right-hand drive Dodge Ram. Somebody's adding 50 grand to the cost by swapping it over to being right-hand drive on the way in. But ours are already at that price, and they're at that price because they are heavy. They weigh a ton more than a Land Cruiser at tear, right? Just parked in the road.
Yeah.
But same tyres. So what's going on here? Because big OEMs don't waste metal, right? They do not use anything that they don't have to use.
Yeah.
But the Marua was made for defence applications. They drop them from helicopters. They need to land at 9 metres a second and not break. They drive through 1 metre deep puddles of mud, and they need to be able to maintain them on location, right? So they're very simple, very robust, but heavy and expensive as a result of that.
Yep.
They're also made on a production line, but they're not made continuously the way that most automotive product is made. Once you decide, right, we're going to build this factory to this production line to build a Corolla, that production line is now going to operate for the next 8 years or 4 years, whatever it is, at 150,000, 200,000 cars a year. It will not stop. Right, and then once it stops, scrap all the robots, put a new set in for the next model, and away we go.
Yep.
These guys, that's not how they roll. It's if you want to buy one, or if you want to buy 20 or 100, you negotiate the spec of what you want. You might need a 50 cal cannon on the surface, on the top of it, or you might need roll bars, or you might need somewhat bulletproofing on the doors or whatever.
Rocket protection.
Whatever it is that you need, and then that's the price, and then that's the time frame, and then we build it and we assemble it on a production line, but manually assembling it.
Okay.
We've got a lot of fancy equipment that does all of the painting and bits and pieces, but it's not like a full-on OEM automotive product. It's a bit bespoke, but close too. So that was perfect for us because it meant that we could say to them, we A, want right-hand drive, B, well, we want you to get rid of those drum brakes on the rear. We need discs. Oh yeah, no problem. No problem. Ask Toyota to make a change like that. Not going to happen. Not going to happen.
No chance.
We need a cup holder. 5 years later, we get a cup holder. So because they make them to order, it means that we can say, right, we want to use your platform here, but we want to make mods so that we don't have to pull out a diesel engine. We want to just bolt in our batteries and our motors. So we don't want you to put any wiring in it. We just want you. We don't want the dash. We don't want exhaust brackets and fuel cap fillers we don't want any of that stuff, right? But we do want battery brackets and motor brackets and stuff like that, like welded to the chassis before it's painted.
Yep.
Part of the build. So we've modified the design. Yeah. And so they said, yeah, no, we can do that. It's no problem because that's what they do.
Yeah.
So, yeah, we can do that. But on the proviso that you become the distributor for the Marua, the diesel version in Australia.
Okay.
And I'm like, well, okay, because that's a pretty good car. Like it's a truck. It's a medium goods class vehicle. It is not a passenger vehicle.
No.
And so again, just saying that was naive, showing my naivety. Like, well, people do it, so it must be doable. Right? Well, I mean, I've got to tell you, that was hard.
Wow, really?
Just going through this homologation process, it is a snake pit.
Wow.
But we're there, and so we've got some more coming in soon, and they're incredible. So you're talking about a truck, call it a truck, a ute.
Yeah.
We're talking about a ute that's roughly the same dimensions as a Land Cruiser, tray back, but it can carry 2.5 ton in the tray, and it's got a Cummins 3.8 litre turbo diesel engine, Euro 5, and Allison automatic transmission, diffs that can handle being dropped out of the sky at 9 metres a second. This thing is so tough, it's not funny. You put 2 ton in the back, you don't even know you've got 2 ton in the back. There's no body roll.
Wow.
It's out of control.
Wow.
Yep. So that's why we chose these guys, and they are brilliant to work with. I mean, Brazil has its challenges, but they're excellent engineers, and the product is incredible.
Wow. So now you're the distributor for
the Marua, for the diesel version. Yep.
Wow. And has that been worth the pain? Was that like a trade-off to get to the chassis and for your EVs?
I think with the fullness of time, understand. Like, I thought all of this stuff would happen a lot faster than it has, mate. It is taking a long time.
Yeah.
In my mind, it's taking a long time.
Right.
So we started this discussion in sort of late 2016 or early 2017, something like that.
Right.
But we sold 4 diesel vehicles to underground mining contractors in Western Australia about 4 years ago.
Okay.
And they've been operating underground. They've used a fraction of the parts.
Wow.
That they would, parts cost was reported to us at 20% of what it would normally cost for a Land Cruiser for the same time frame.
Wow.
But they're 4 years old. Like, these companies don't have 4-year-old Land Cruisers.
Yeah.
They don't have them.
Wow.
They last a couple of years, 3 max, depending on how they use them. So that part, I think, will help us to get the traction with the Bortana as we go into production. It's like we've got this evidence, guys, by then that we've got 5-6 years underground with the diesel vehicle. They actually will last a lot longer, and they actually do carry a lot of weight, and the brakes work and everything's cool. So I think it'll be beneficial. But I am actually a little bit excited bringing these 3.8s. It's a bigger engine with the Allison automatic. I think people are going to really like it. It'd be an incredible, I mean, as an off-road vehicle, it is an incredible off-road vehicle. Wow. So capable.
Wow.
Yep.
Wow. It sounds like it's one of those things, what you're trying to achieve when we're talking about earlier in the episode, when we're talking about Canada changing the law for the Laddertube, something that made a lot of sense. It wasn't a big thing in comparison to this, for example.
Yep.
EVs in underground mines that are traditionally run with diesel vehicles at a massive scale. Like, how many Land Cruisers would an average mine have?
I call it 25, but some have, like, there's one in Australia that's got 250, and there's one in Indonesia that's got 1,500.
Yeah, right. Yep. So a big scale difference there, but heaps.
Yep.
They're used to using them. Their whole systems
is all based
built around this thing.
This change is hard.
It's not small. Even though it makes a lot of sense. Yep. It sounds like you're really finding out how long it takes to change something that big.
Yep.
What do you think? What's your projection for when this might actually shift?
Okay, so from experience, and granted it's only over a short period of time world-wise, but Laddertube, there was a clear demarcation at the 7-year mark where instead of having to convince and justify for every new customer, all of a sudden we didn't have to convince and justify anymore. And mining companies were including the product. Mining companies that we've never spoken to, they're in Sierra Leone or, random places around the world, and they're including it in their tender documents to their contractors that you must use Laddertube. And we're getting these emails going, that's cool.
That is super cool.
Right, so year 7. Yep.
Right.
Edge Protector is now at year 6. I think that the next year, it feels like, because it's actually starting to kick.
Up on the hockey
feels
turf.
like in the next year, it's going to happen. So I'm looking at 7-year timeframes at the moment.
Yep.
Well, if we count this year as being year 1, we got 7 years before, but I don't think it'll take that long this time. I can't imagine it. Like 7 years is probably, if we make it that far and we're doing it then we have absolutely got it right.
Yep.
Yeah. Because the demand pool for the concept of an electric vehicle working in underground mines is enormous.
Yeah.
They really, really want it.
Right.
But they won't invest in helping companies to set up and try. They want to have something that already is proven, like a 20-year design of a Land Cruiser.
Sure.
If we're going to do something new and it's a trial, it's not. why can't somebody make 100,000 of these and drop them off at the door? Right, this is where we're at.
Gotcha.
And I think that there's an opportunity there for the mining industry to maybe work with the suppliers, because there's only a handful of us that are serious about this in the world at the moment, and work with them and say, right, what do we need to do together to make this happen?
Yeah.
Because it matters to us, and you won't exist if we don't make it happen and use it. How do we work together? Because all of these companies that are doing it are relatively small private companies.
Right.
Yep, all of us have been around for a while doing various things, and we're doing this at the moment as well. And there's a lot of interest. It's pretty cool. But could you imagine if it takes you 8 months from beginning to order components to assembled vehicle, and you want to get to, say, a meaningful volume, say 50 vehicles a month, right? And that would do 10% of what's required in Australia. 8 months times 50 vehicles that are all being purchased, like everything's being bought in advance and paid for. The capital in operating costs, it's enormous. This is not small bickies, right?
Nah.
And of course, these relatively small private businesses, we run on pretty tight margins, and we have to manage our cash flow because we don't have public markets to go and tap to get an extra 100 million here and there. Like, it's a snack for the big companies. It's not a snack.
Right.
So how do we do that? That's the biggest challenge.
Yeah, wow. That is a humongous challenge, but definitely one, and I can see it in your eyes. You know the value proposition of what you need to say and how you need to propose it to, for example, a mining company and you've got great relationships with lots of them. So I reckon you'll crack that nut before too long. As we round out this episode, I've just got like a million little roads I could run down, but I'm conscious of time. If you're open to coming back, we could have some mad V2 discussions. But Steve, I want to ask you about if you can distill maybe a couple of key learnings over your journey as a founder and a business leader. What have you learned that you could pass on to someone else that you think could really help them, right? So what have you learnt along your journey, that bit of business wisdom that you could pass on?
Every business is different. Every product is different, and sometimes every market that product goes into is different, and you've got to treat them differently. And so I might have some really great advice. I probably have some okay advice, some good advice, but it might be really great, provided I understand what your market is and what your product is and does and how it operates within that market, because everything's different. You've actually got to think about things from first principles. You cannot just get an MBA, have a look at what the four forces or five forces bloody thing is and go, right, this is what we have to do. No. Yeah. Right. You have to understand how things actually work for you in that environment, right? And I guess that's advice. Understand your market, understand what your product does and what it competes with. Don't just take advice, because people tend to give advice based on their experience. I can only do that, right? Yep. And if I do that, it might be totally wrong for your product.
Yeah. Yeah, that's really interesting, because what I observe of your journey and how you've built things and the products that you've released and are marketing, they're such great fits. That is like one of the keys that, from an outsider's perspective, that I'd see on your success is that every product you've made, no brainer. Like, it's a product that almost sells itself, right? Yeah. Would you say that?
Yes, but not straight away, right? So in every case, we've been told by people at the beginning, this is a terrible idea. Like, why would you do this? It's not going to work. It's a bad idea, right?
Really?
Yes, by very, very capable, very senior, very knowledgeable people would say, what do you think? Like, no way.
Wow.
Don't do it. Yeah. That is the approach. However, in every case, it's been obvious in hindsight.
Right.
So it's like you kind of have to have knowledge of the future, be able to see what things look like after the hump of all of the people being naysayers and challenges and problems and fighting the fight all the way through, and just see yourself there, right? If you see yourself there and you can see that there's ways that you can get through all of that stuff, well, you might have a win.
Wow. Yeah, that's pretty insightful, because you're right, in hindsight, obvious.
Yeah.
But
Not
on the
at the time.
journey, maybe not.
Nope.
That's fascinating. I think that's a really good insight into innovation. Right. Thank you so much. I'm going to wrap it up. This has been absolutely phenomenal. And if I get the chance to sit down in this studio again, we will easily have another hour episode in us. Steve, thank you so much for joining me. It's been an absolute pleasure.
No, I've really enjoyed it, Caleb. Thanks very much.
Please hit the subscribe button and the like button, and I would love to hear what you think about it in the comments below.